Okay, thank you very much. My name is Malasa. I will try to show you the design of steel connections using IDEA Statica. And now let me open the model that I have already modeled and analyzed as well as designed in tutorial 1, 2, 3, and 4. Now this is the tutorial number 5. Now let me open the steel roof shed model. Now here robot structural analysis professional is opening the steel warehouse that I have designed before. Now I will show you the design of if connections. Now here the robot structural analysis professional open the previously designed steel structures. Here all the members are designed. Now I'm going to design the one of the if connection. So I will try to select the critical if connections. Here this router, this router, this router, this and this have similar if connections because they have the same size of router and the same size of the main column. So I will try to select the critical connections. So in order to select the critical the connection, I need to observe the internal force of the connection. So now let me observe the internal forces of the connection here. So I will try to just go to the result menu and the diagram on table. So here as here this is the moment connection. So I will try to see the moment here. So now I will select the okay. So here robot structural analysis so here I will try to select the logic combinations here. So I have to select all the combinations. So now I have to select all the combinations for the ultimate limit state here. And then just go to the result menu. And the diagram on the board. Actually here this one apply. Okay, now here my is the major moment, and now the moment is displayed here. Now let me make it of the joint number. So here now there is a moment 474 at this connection, 729 at this connection, 717 is at this connection, and 770.58 kilonewton meter is at this connections, and 729. Oh, so I can I can select the critical one is I think this one. I think this connection and these connections have almost the similar movements. So here the amount of the critical moment is located at these connections. These connections. That is the connection number 174 here. Okay, now So now, okay, this one is 770.57, almost, these connections and these connections are similar. So I will select, the this member, and now and this member, and here these connections also, these connections, this joint, that is 232 will be selected, 232. Now let me open this one. Let me delete the rest joints, because I need to use the joint between this rafter and these columns. Okay, so just go to the audience menu and idea statica. So click this idea statica. So all the internal forces of joint 232 will be exported to the idea statica. Now here all the internal forces of joint 232 will be exported to idea statica. So idea statica will be using this results, the moment, the shear force, and the the normal force for the design of the connections. Okay, now the idea statica exports this joint here. Okay, now click these connections. Okay, now it is taking more time, because all the results of the robot structural analysis at joint 232 will be exported to the idea statica. Now that is why it is taking more time. Okay, here all the joints are exported to this one. A joint 232 is exported here. So I will not use joint 234. Just delete this one. Yes. So delete 244. I don't need this one also. So delete this one. So the only joints that I'm going to design is joint 232 here, this joint. So select this joint, then the click open. So idea statica will open this joint. So here, this connection to 31 has been designed before, and connection 50 is also designed before. So this is the rafter and this is the column. Now this is the bearing member, and okay, now idea statica is opening joint 232. Okay, now generating the projected data. The amount of movement at connection to 32 is very high. That is 770 kilonewton meter. Okay, here now the very good. This is the joint. Yeah, this is the joint now. So this one is a join. Now let me, you know, delete all the so now here this one is the governing load, I think. Okay, now okay, 685, and this one is 85, and this one is 649. This one is the critical load combinations. So we can delete all the rest load for a simplicity of the analysis. Okay, now delete this one. So now here, so delete this one, delete this one, delete this one, delete, 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 delete. So now delete. Okay, now we have to delete this one. We have to delete this one also. So delete this one. Okay, I need to delete this one. So delete this one. The only load that I am going to use is this combination. Okay. So I have to run the calculation here. This is the arrangements of the bolt here. This is the arrangement of the bolt here. This is the main rafter. And member G is not specified, connected to column 41, this column. And the material is 355, the thickness is this 20, the connection type is this bolted. If I wanted to use a welded connection, I can click this one. So the top clear the top distance is this one is it is 10 millimeter from this up to this, it is 10 millimeter. The left side offset is 0 because it is flush with the edges of the flange. Okay, now the bottom length of the indie plate is, it is 480. I think from starting from here to here, it is 480. Now the right side is, which is similar to this face, which is an offset of 0 because it is flush with the edges of the flanges of the rafter and the collar. And when we come to also here the bolts, I'm using M22 10.9 bolt here this bolt, and all those are the layers of the bolt here. Just when they come to here, the first one is, it is 54, I mean it is minus 70 here. The first bolt is located 70 millimeter from the edges of the plates, and now the second bolt will be located also minus 70, meaning it is minus 70 is toward this the member. Here it is total toward the member, it is minus 70 here, minus 70, minus 70, minus 70 here. So this is the top plates. So from the top layer here, this is the top layer, and the left layer is it is minus 60, meaning that this this bolt has to be located 60 millimeter from the edges of the left edges of the plate here. It is the dimension is indicated here, it is 60 millimeter. So, and this one is also the lower the bottom layer is also in similar manner. So here in similar manner, so it is minus 54 is it is this one here, the distance of the bottom, the distance of the bolt located at the lower parts of the bottom parts of the plate is, it is 54 millimeter from from the flanges of the rafter here, and then the rest, it is minus 54. So, and the other is, it is 108. When we go to down, it is positive. It is positive. So it is 108 here, and then 70. It is it is 70. So the distance from this port to this port is it is 108, and the distance from here to here is, it is 70, 70, 70, 70, and 70. So okay. So now let me uh, you know see also the right layer here. This is the right layer is also in similar manner. It is 60 from the edges of the the bolts at the right sides of the plates is located 60 millimeter from the edges of uh, the plate here. It is minus 60. So this bolt is somewhat is located at the center of the zone, and the left one is also nearly at the center of the plate here. Okay. So when we come to also this, the shear force transfer mechanism is, bearing tension mechanism here. So all the welds, all the welds that are applied to the blade, and the stiffener is it is 8 millimeter. So here, this is the material is, it is 355 H355, which is the grade of the material similar to the grade of the column and thereafter. So here, just when we come to also the stiffener, the stiffener is, the material is, it is S355. Now the thickness is, it is 50. The location on both sides, on this and on the other opposite side, and the exposition is 180, which is from this up to this is, it is 180, and the inclination is, it is 45 degree, and the width is it is 0, because the width is the distance from this this web to the edges of the stiffener. So the edges of the stiffener should be located on the faces of the webs. So that is why there is no clearance, or there is no distance between the two members. That is 0. Offset from the top, it is also 0. So offset bottom, it is 0. Repeat. So here, the default material for the weld is S355. Okay, when we come to also this stiffener, it is okay, and this stiffener, make the material is 355. Okay, this stiffener also, it is make, it is 355. The grades of the weld. So, and when we come to also this stiffener, so we have to make as 355. So all the rest values are similar. So when we come to also the hatch, it is 355. Okay. So this one, all the values are described. So what is left now? The analysis. Now let me run the calculation here. So to run the calculations, I have to click this button here, calculate. Now robot structural analysis is analyzing the connection to 32. Now here, this the after the completion of the analysis, the Idea Statica will provide the uh, final results of the connections. That is the plates, the capacity of the plate, the capacity of the bolt, the capacity of the welds, and the buckling resistance. All those values will be provided in terms of the capacity ratio. So now robot structural analysis is, the analysis of the joint by using the idea Statica is completed here. So now the analysis is, it is 100% completed. The plate is 0.4, which is less than 5%. It is okay. The bolts is the capacity ratio of the bolt is it is almost 0.98. So 98% of the capacity of the bolts is used. Now the word is also 98.3, which is 98.3% of the capacity of the bolt is utilized. So now here what's left is the buckling. So here, if you see this bolt here, this is the critical bolts. The critical bolts. That's the 98% of the capacity of the boat is utilized. All the rest bolts are not critical. They are used under their capacity. So here so now here I have to run the buckling because not calculated here. So to do this we need to go to the check menu here. So here now go to the calculate button here. Now stress strain buckling analysis. Now click this one so that the idea Statica will analyzing the buckling of connection to 32. Now after the completion of the analysis here, the buckling factor will be displayed here. So the idea Statica recommends that the buckling factor should not be exceed 15. So we need to be take care just while we're getting this value. So we need to make it greater than 50. If it is less than 50, we need to increase the thickness of the elements. It may be the plates, or it may be stiffeners, or even we need to increase the number of bolts, or the grades of bolt, or the diameter of the bolt, so that the buckling factor will be greater than 15. Okay, now the idea Statica is still analyzing the connection to 32. So it is taking more time. Because the capacity of the bolts and the weld is almost closer to this maximum capacity. Now the buckling analysis is completed. Here now the buckling is 8.61, so it is less than 50. So we need to increase the thickness of the plate here in order to increase the buckling factor. So to do this we need to here there is we can see the the buckling here. Just click this one here this is 8.61, 11.48. All those are the buckling mode. The idea Statica has 6 modes of buckling by default. So here the first one is 8.61, the critical one, and the second one is 11.48, and the third one is it is 50.88. So module 1 and 2 are failing. Okay, so we need to increase the the okay, so let me go to the design. So now here go to the in the plate here. So I have to make it uniform. Just 25, no, sorry, 225. So now let me run the analysis here. So now the okay here a little bit the capacity of the ports, it is the percentage of utilization is much, it is 97.3. Previously it was 98. So now let me check once also the buckling. Okay, now the idea Statica completed the analysis of backlink here. To somehow it is 8.63 till now. So now let me okay, now let me measure it. So now buckling shape here. Okay, this is the buckling shape. And this is the buckling shape. Now let me see the equivalent stress here. Here this is the equivalent stress. So here this is okay, and this is also okay, this is also okay, and this one, this is okay, but somehow the stress around here is closer to the yield stress of the material. It is 355, and this one is around 355, so it is closer to the yield stress of the column. So more or less it is it is okay. So the stress distribution is okay. Here it is okay. So if we provide stiffener here, this stress will be reduced. And if we provide also stiffener here, diagonal stiffener like this stress will be reduced. This red color becomes yellow. So that is why we are just recommended using the stiffener at the point where there will be the maximum equivalent stress. Okay, that's good. So when we come to also strain check here, just we can check the strain here. Here there is a maximum strain around here. In the previous, during the visualization of the equivalent stress, here there is the higher stress, the higher equivalent stress around here. Now let me show you. Now equivalent stress will be maximum at this zone here. Okay, at this zone. That is why strain is high here. Strain check around this, around this there will be a maximum strain here, just like this. It is around 0.15. So the buckling shape, I have seen the buckling shape before, and now here, the deformed shape. You can see, the deformed shape. This is the deformed shape. uh, so here there is the maximum deformation here. Here there is a maximum deformation here. So after checking all the results here, we can see that the analysis result is here. This is the analysis, and this is the results of the plates here. The results of the plate here. There is a maximum deformation here, as you see here, and the bolts is also here. If you click this one, you can see all the bolts here. Bolt forces. You can see the bolt forces. If you collect this one, you can see how much forces will be exerted on each individual bolts here. This is the critical forces, which is around I think B2, which is 212.4 kilonewton. Force is exerted on these critical bolts that we have seen in previous session. Okay, the maximum, the critical bolt is located here. So and all the rest, all the rest bolts are subjected to a lower force, 140, 71, 52, 17, and just like this. So the only critical one is this one. Okay, when we count also the bolts, so collect this one, so that we will see the resistance of the weld here. As you can see, the the ratio, the utilization ratio. Yes, it is low. This shows that our weld is safe. So all the weld is past the requirements. This is green. So when we come to also the buckling, it is okay. So here, so I think this is for the stress strain analysis. When if we want to also calculate the stiffness analysis, just we have to go to this mode, just like this. So area Statica will shift from this mode to this mode. So we can run the calculations. So to check the analysis of the stiffness, or just we can check the capacity design. Here we have to jump to this mode, collect this one. So idea Statica will shift from the stiffness analysis to the capacity design. So we can run the analysis of the connections in order to check whether the capacity design is okay or not. Just run the calculation here. Now the idea Statica is running the calculations and the designs of these connections, and finally we can see the results here. So now we are running the design resistance of the joint. The stress strain analysis is okay, the stiffness analysis is also okay, the capacity design is okay. Now here we are running the design resistance of the connections, and later the footage will be also analyzed. So here we are using 11 volts in this side, and on the opposite side 11 volts. Totally 22 volts are used because there is high moment here. It is greater than 770 kN moment is exerted here at the beam and as well as at the columns. So that is why more volts are being used here. And now, in order to increase the resistance of the connection, we need to use the bracket here, because there is high moment here. So if we don't use this bracket or this hunch, our connection will be failed. So to increase the number of volts, we need to increase the length of the indie plate. So to increase the length of the indie plate, we need to use hunch. So our model, the previous model is it doesn't have any hunch, but here we need to use hunch. If you see our model here, sorry, it is too busy. Okay, now the analysis of the design resistance is completed here. Okay, it is the weld it is 98, which is similar to the stress strain analysis, and the bolt is 97, which is similar to the result which is obtained during the stress strain analysis mode, and the plate is 0.1. It's okay. So the here the fatigue analysis and check. We can check even the fatigue analysis and check here. So now run the calculation here. So now here we're at the stress strain analysis mode. And so I will show you the how to generate reports of the connection design using the idea Statica. So now let me run once the backlink. So here, in order to check or in order to generate the report, you can click this icon here, this menu, this report menu, so that the idea Statica will be generating all the calculation results. So the detail calculations that gives this result will be displayed in detail by the idea Statica. Okay, now here just the reports are being generated. So just in order to create a report, you can click simply this menu, so that idea Statica will be generating all the detailed reports of the connection to 32. the contents of the reports are here, projected data, paragraph, material, all those. If you wanted to, get a theoretical background, you can select just like this, but I don't need this one. And the software information, you can click this one, so that you will be getting the software information. So here just you can see the project data, the material that we have used, the project item connection name, the design here, count to 32, connection to 32. And here this is the 3D, or this is the column, the column size, and here the rafter size. This here 400 and here here 400 is exported from robot structural analysis. All those sizes are not changed, they are taken from the robot structural analysis. Here, this is the material that I have used during the design of the steel structures in robot structural analysis. Here, this is the governing load combinations, and this is the bolts, the grade of the bolts, and the diameter of the bolt. Here, all those results are listed here. This is all the connection, and this is the stretch strength uh, map here. All those results are displayed here, so just you can here this is the buckling mode, because we have already analyzed the buckling. Here this is the the factor 8.63, 11.51, just like this, all those. And this is the core setting. I didn't show you before. Here you can set all the setting in the code preference tables here. So here, what I'm going to show you is, the distance between bolts T, which is 2.2 times is the diameter. This is the minimum bolt spacing. Uh, and the distance between bolts and edges, that is E, which is 1.2 times D, adds uh, edges of the edge distance and the any distance of the bolt. This is the bolt spacing code. Now all this are the reports, so you can convert this into PDF. So here this is the material. Just if you click this one, you can get all the lists of the material here. The material, the detailed descriptions of all the materials that have been used before. It's like this here. This is here 400. You know, here 400 is the height is this one, the thickness is this one, and all the information here. If you click IP80, just you can get this one. IP80 just like this. So IP80 is for inches. So now it's for the plate here, just you can see the thickness of the plate is 10 by 200. So now here have 400, it's just like this. So all this are and the bolts, when we come to also the bolts, just it is 28.8 volts. Okay, so now let me come to the design. So now just come to the project and save my connections. Okay, I think this is all about the connections of uh, the ifs, that is the connection to 32. So now let me show you the results are not similar. Similar joint, which is designed by the ideas that the robot structural analysis, which has similar results obtained by the idea Statica. Okay, now let me open the connection. Now let me go to the connection here. Sorry. Just go to here, still design the connections. So we have designed previously, connection to 32. Now here I have designed the connection to 32, also this one here. This one, right click. Okay, now it's my PC is busy. Now property here. Okay, here this is the connection design using robot structural analysis. Uh, so here connection view. This one, if you see here, I have used 11 bolts diameter diameter 22, and similarly here, when I go to here, here the diameter is 22 and the class is 10.9. Here now let me go to the idea statica here. Sorry, here. So just just to compare the results of the idea statica and the robot structure. Here now the bolt is M22 10.9. Here similarly, the bolt is M22 10.9, and the blade size is 900 by 300. The blade size is this one. Here from this, we see here it is 480 from this up to this, and from this up to this it is 400. Nearly it is 900. 900 by this one is it is 30. It is 30. So, and the thickness is it is 25 in also in idea statica it is 25. This thickness it is 25. So the bolts are with a spacing of 80 millimeter, but in idea statica the spacing is nearly 70. More or less it is similar. So the weld size is it is 8 millimeter. The weld size, now let me come to the weld size here. It is the weld, it is more or less it is beam weld, it is 10 millimeter, 10 millimeter. Just I can make it 8 in order to make it similar. Just I can make it 8. And the lower flanges it is 8. So beam weld it is it is for flanges it is make it 8 in order to make similar. So now apply. So now calculate. Okay, now here the so close this one. It is 0.89, nearly it is 90. The utilization ratio is it is it is 90. So the results, the connections, the connection results obtained by idea statica and robot structural analysis is more or less similar. This is 90% of utilization factor, and in idea statica is also it is 97.3, which is more or less it is similar. So this is all about the connection design. If you count also the number of bolts, 1 2 3 4 5 6 7 8 9 10 11, 11 bolts are used. That is 11 bolts in this side, 11 bolts on that side. That is 22 bolts. 22 bolts. But in robot structural analysis also it is 11 in this side. Let me show you here. The 11 in this side, 11 in that side, which is 22. 22 bolts are used. So the same, hatches are also similar here. Hatches are also similar here. So this shows that the connections uh, uh, results obtained from the idea statica and robot structurals analysis are identical, more or less. So this is all about the connection design. Thank you very much.